Now we come to the second section on interpretation of PQRST patterns. Calculation of the heart rate. The heart rate is calculated by measuring the number of small squares between two successive R waves. 1500 divided by this number gives us the heart rate per minute. The standard ECG paper runs at a rate of 25 millimeters per second. So each small square represents 0.04 seconds and each large square represents 0.2 seconds and 1500 small squares represent 1 minute. In this ECG, the RR interval measures 10 small squares. So the rate is 1500 divided by 10 equal to 150 per minute. A rate above 100 per minute is termed as tachycardia. In the second ECG, the RR interval is much prolonged. Let us count it taking help of the large squares in thick lines after every 5 small squares. The RR interval is 28 small squares. So the heart rate is 1500 divided by 28 equal to 54 per minute. A rate below 60 per minute is termed as bradycardia. In this ECG, count the RR interval. It is 18 small squares. So the rate is 84 per minute, that is within normal range. So normally the RR interval should be between 15 to 25 small squares or 60 to 100 per minute. Now in this ECG, the rhythm is irregular. Each RR interval is different. So in this case, count the number of R waves in 15 large squares which represent 3 seconds and multiply the number by 20 to get an approximate heart rate per minute. This tracing shows 5 R waves in 15 large squares. So the rate is about 100 per minute. So before a heart rate is calculated, see whether the rhythm is regular. We must also remember that RR interval actually measures the ventricular rate. In total heart block, where P waves do not correspond with the QRS complexes, the atrial rate should be calculated separately by measuring the number of small squares between two P waves and dividing 1500 by this number. In this tracing, the PP interval is 15 small squares and the RR interval is 50 small squares. So the atrial rate is 100 per minute while ventricular rate is 30 per minute. Clinically, what we count by palpating the pulse is ventricular rate. Atrial rate can be seen only on ECG. Axis deviation. To look for deviation of electrical axis of heart, we must study leads 1 and 3. Normally, QRS complexes are predominantly upwards in both these leads. In left axis deviation, there is a prominent R wave in lead 1 and a prominent negative deflection either Q or S in lead 3. In right axis deviation, there is a prominent negative deflection in lead 1 and a prominent R wave in lead 3. To avoid confusion, remember a simple mnemonic: left leaves and right reaches. Imagine lead 1 above and lead 3 below. The QRS complexes seem to leave one another in left axis deviation, that is left leaves, and QRS complexes seem to reach each other in right axis deviation, that is right reaches. This ECG shows left axis deviation. Left axis deviation is seen in left ventricular hypertrophy, left bundle branch block, and inferior wall infarct. This ECG shows right axis deviation. Right axis deviation is seen in right ventricular hypertrophy, right bundle branch block, and anterior wall infarct.